Hi, my name is Katie. I'll be doing friction between dirt bike tires in the road. What is friction? Friction is a contact force between two objects rubbing against each other. Always remember, when friction is being used, it is always opposite to direction of motion. A clear example of friction in motion is a lawnmower. The direction of the lawnmower is to the left, while the force of friction, or the wheels, are moving to the right. There are several types of friction that can be used for this project. I will only be using three. The first is static friction. Static friction is when two objects have a force of contact but does not move another object. An example is the picture in the background. The tire is in contact with a rigid surface but neither is moving one another. The second type of friction is kinetic friction. Kinetic friction is when two objects have a force of contact and are in motion with one another. For instance, a dirt bike tire and the rigid surface beneath are interacting and have a frictional force while in motion. And as for the last type of friction, rolling friction is when a round object is rolling over any type of surface. Example would be when a dirt bike's tires are constantly in contact rolling over the desert ground. To make kinetic and rolling friction a little more clear, I have made two short clips about the two. As you've seen in the two videos, kinetic and rolling friction were being used because the tire and surface were in contact, were interacting, and velocity was involved. How in the world do you calculate friction? Throughout all of Physics 101, we all have seen the different types of formulas that were in waves, energies, etc. They all seemed pretty simple. As for friction, this happens to have several different formulas with diverse meanings. First of all, friction alone has its own formula, as well as kinetic, static, and rolling friction. But first let's start off with the main equation for friction that the formulas can plug into. The friction equation is the force of friction equal to that of the coefficient of friction between object and surface that is multiplied to the normal force. To make this a little bit more clear, we have the formula Ff meaning force of friction, Fn meaning normal force, the Greek letter mu, which is the coefficient of friction between object and surface. All three of these fit into the friction equation. Now adding kinetic, static, and rolling friction, we have the formulas mu k meaning friction, mu s meaning static friction, and lastly CRR meaning rolling friction. An explanation of how to calculate friction using kinetic or static friction is by having all of the information needed in order to plug formulas and numbers in. For instance, a dirt bike that weighs 250.4 pounds, which is equivalent to 113.58 kilograms, is in motion on the desert surface. The kinetic friction between the rigid ground and dirt bike tires is 35 newtons. Determine the coefficient of kinetic friction between the two objects. When using this scenario, we must start with the normal force. The normal force is equal to mass times acceleration, which is similar to the force total, what we learned about in force. So to plug this in, we have a mass of 113.5 kilograms times the acceleration of 10 meters per second per second. We get the answer of 1,135.8 newtons. After finding the normal force, we will then determine the force of friction, Ff, by using the equation Ff equals mu k times normal force. However, in our scenario, it asks to determine kinetic friction. So to fix this, we must move force of friction to the right side of the equation and mu k to the left side. So now we have the equation mu k equals force of friction divided by normal force. This is equal to 35 newtons divided by the force of friction 1,135.8 newtons. We will then get an answer of 0.031, which is the kinetic friction being used. To conclude, friction can be used throughout any real-life situations. It can go beyond more than just a simple rubber tire and rough surface. But although, just remember, friction is always similar to force, as we all know the interaction of two objects.